Okay, welcome everyone to another Call the Doctor. Before I get started, are there any questions from the audience? Okay, hearing none. Tonight I thought I'd talk about two packages that I haven't talked about a lot previously. One is H5netcdf and the other is xarray. And both of these aim to put a layer on top of the H5Pi interface with the aim towards making it easier to use. And you'll kind of see how that works as we go through this notebook. So in the notebook, and I put a link to this notebook in the forum if anyone's curious to look at it directly. So in this notebook, I was going to go through looking at the same file with H5Pi or H5Pi-D, and then H5netcdf, and then X-ray. And then we kind of compare and contrast. And if one of these packages seems more suitable for you, you may want to look at it. But bear in mind that H5netcdf is built on top of H5Pi, and X-ray is built on top of H5netcdf. So you're still using the good old HDF under the covers, even though you may not interact with it the way you normally do with H5Pi. All right, so here we are. In my notebook, I'm going to import H5Pi, H5Pi-D, H5netcdf, and X-ray. If you say are just using X-ray, normally you don't need any of these other imports, but I have these imports because I want to explicitly show each of these interfaces. So I will just be running through the code. And I should say that some of the content here was taken from a tutorial on SCDF, which I liberated. And this is how you create the content environment, all the packages you need to run this notebook. So first, let me do a check on HSDS. So in Python notebooks, if you have a exclamation mark in the front, that means run it as if you run the command line. So hsinfo is a command line tool that's included with H5Pi-D, and it's going to use our configuration to get the endpoint to the server and use a username and a password, and then it comes back saying I have a home folder as /home/John. The server version is 0.9.4. There's 4 nodes. It's been up for 6 hours, and the H5Pi-D version. So, and let me say, firstly, about the configuration I'm running here. So I'm running this on a Windows laptop, but HSDS is actually running in this Linux service environment, WSL, that provides a genuine Linux kernel that the server runs in. So I found HSDS works better running in Linux or Mac OS than Windows. And here you kind of have the best of both worlds, right? You're running HSDS in a Linux environment, even though it actually is on the same physical machine. But my notebook is just a regular Python notebook running on Windows in VS Code, I should mention. All right. Okay, that said, in this first part, we're not going to use HSDS. So here I have a file name, series, ebaf, TOA, blah, blah, blah. And we have a HSDS folder path, HDF5://home/John/netcdf. So in HSDS, this file is in that HSDS folder. And I have the same file in a regular Windows folder using this path. Okay. And what we're going to do in the first step is set the file path to the Windows folder plus the file name. And then we'll check that's really a file. And that's the path. And yes, it is a file. And now here, Again, we're using the exclam to run a command line tool. If that file path starts with HDF5, I'm going to run the h5.pyd HSLS tool. And if not, I'm going to run the h5ls tool. Okay, they have the same effect in the list contents of the file. The -r says run this recursively to go through subdirectories and such. And so we'll do that, and we get this content. So we have a root group, we have a data set called lat, one lon, 1 month, and then a bunch of three-dimensional data sets. And what we'll discover as we go through this is that these TOA underscore data sets are all the primary data sets. The lat, long, and month, you see they're all one-dimensional data sets. And the extent of those dimensions match the extents of our three-dimensional data sets. So these, in fact, are dimension scales for each of these data sets. So it's a three-dimensional data sets, and apparently we have one dimension corresponds to time, the month, the other to longitude, and the other to latitude. Okay, so here I'm going to, if, same kind of trick, if we start with HDF5, I'm going to use h5pyd to open the file, and otherwise I'll use h5py. So we are in this case here, and I'll print the root ID, and you'll see it's a large integer. If this was HSDS, you'd have a GUID instead. We'll see that later. Okay, and now I'll just go through each of the top level objects and print out the information. And much like the H5LS, we see the names and the type and the shape of the data sets. Okay, so now let's grab one of the data sets and we can list all the attributes. And if we look at the attributes that we see some which are correspond to what's called the CF conventions, like CF name and units and valid min, valid max. And then we have this one dimension list. So this is like a special attribute name that's used by HDF5 to connect the dimension of a particular data set to another data set that describes the dimension. So like we had here with the long and lat and month. And if we take one of these, we see we have an array of arrays. And if I look at that first array and get the first element of that first array, I get a object reference. And if I take my file handle and I use that object reference, I get a pointer back to this data set, this month data set. So object references are a neat way in HDF5 to refer to another HDF5 object. And the reference can either be an attribute or you can have a data set of references. And as opposed to, say, hard links or soft links, you can have them in an array, a data set, and they don't participate in the reference counting. So if you have an object in HDF5 whose only reference is one of these object references, then that object would get deleted when you close the file. Okay, it's not the case here because we have these things that the references are pointing to actually linked to the root group. All right. If anyone has questions along the way, please stop me and I'll be happy to answer. So it turns out in H5Py, there is a high-level API for working with dimension scales, which I spelled wrong. So we do dsit.dems we have dimension, three-dimension scales, and I can iterate through these and print them all. So we have, for the first dimension, there's one dimension scale month. For the second dimension, there's one dimension scale called lat. And for the third dimension, there's one dimension scale called longitude. Okay. And there are more operations working with dimension scales, but basically they are a kind of high level wrapper that makes it easier to deal with than dealing with the object references directly. All right. Okay. So we're done with H5 pi. Now let's try the same operation using h5netcdf. So I'll take my file path and say h5netcdf.file file path. And if I just print the file handle, we get a lot of information. So I guess h5netcdf has a philosophy to be more verbose in terms of how it represents these objects. So you see that we have the dimensions, no groups, these variables. So one confusing thing when you work with h5 pi and h5netcdf, what is a data set in HDF5 is called a variable in netcdf. So these variables are actually what in h5 pi we would call a data set. And then we have these attributes, all good. And similarly to with h5 pi, we can just get a data set. And you'll see that we list not just the data set, but the dimensions of the data set and its shape and its type. So I would say in h5netcdf, the philosophy is to treat these dimensions as a more integral part. You don't have to, but by convention, oftentimes when I work with netcdf for files, I'm expecting to see these dimensions linked to each data set. Okay, there's more we can do with h5netcdf, but let's move on to xarray. Okay, so here I'm going to use xarray.open dataset. So again, confusing. A dataset in xarray is not an HDF5 dataset, and it's not a netcdf4 variable. It's the whole thing. It's the file, basically. We're going to specify engine. There's different backends you can use. I'm going to say h5netcdf. And this driver is, for now, it's just none. But when we're using HSDS, you can specify the driver as h5pid. Okay, so let's do that. And now we get even more a visually exciting representation in Python notebooks, at least. So you show you all this information. You can expand and contract these guys. So it's a very nice interface for using the Python notebooks. So remember we had month, long, and lat as dimensions. Here, they're actually become part of the API. So you say ds.month, and we'll see we get an array of 1 to 12 with attributes, and ds.long, the same deal. So this is degrees longitude. So 360. And then latitude will be minus 90 to plus 90. All right. And another cool thing. So if I do this ds.toa underscore sw all.climb, I'm referencing that three-dimensional data set. Let me see that. And one nice thing xarray has is they have built-in statistical functions. So I can say ds and my data set dot mean and specify which dimension to iterate over and get a monthly mean of these values and store those in an NumPy array. All right. And one nice thing they have is there's a built-in plot function. So this object I got back from the mean function, I can just say dot plot, and it's going to make a nice plot. And what you'll notice about the plot is that because these dimensions are associated with this data variable, that the functionality to do the plot already knows to label this as degrees longitude, degrees latitude, and the scale for the values. Right. So it's quite convenient. If you ever had to wrestle with pretty matplotlib plots by hand, this is really nice. Okay, so that was a quick whirlwind tour of H5Pi, h5netcdf, and xarray. But what I really want to dive into now is how this works with HSDS. So let's go back, way back. And I'm going to change this line to this. And let me clear all the outputs. Okay, so now our path is HDF5 :///home/John/netcdf. So this is a path to a domain inside HSDS. And if I say os.path is file, it's not a file because the operating system doesn't recognize that as being a file. And here I'll do HSLS instead of H5LS, and it looks much the same. And if I open the file in h5pyd now, h5pyd file, we'll see that the root ID is a GUID, as opposed to before it was a long integer. Okay, but from this point onward, with h5pyd, everything will work pretty much the same as before. So let me just quickly step through these to convince ourselves that's true. Oops, maybe not. Yeah. Oh, I will do this. Okay, I need to finesse this a little bit more. Anyway, so same kind of thing. We have the data sets and the type and the shape for data sets. And we can get a data set and list the attributes. Okay. And another slight difference, when I look at an object reference in h5pyd, they're actually a string. You can view them as a string that it references the data set by the GUID, right? And I guess it's true both of object references in h5pyd are the library, is that if you change the path to a particular data set and you have an object reference to that data set, changing the path doesn't affect the validity of that reference. Okay, so here in HSDS, we reference the data set using a GUID, there's different mechanics in the H5 library, but the effect is the same, is that regardless of how the path to that data set may change in the future, you'll always get the original object. And this should work the same. And the dimensions works the same. And we do it. Okay. So moral is working with H5 Pi versus H5 Pi D, in 99% of the time, you don't need to think much that it's library or HSDS. The only thing you need to do is when you open the file uh, or domain in for HSDS, use h5pi_d that file, and in h5pi it's h5pi that file. Okay, and now things are even easier with h5netcdf. So here, so I don't have this if code. I just say h5netcdf.file file path. And if it's a Unix file path, it will open it indirectly using h5pi and h5 library. If it's an HDF5:// it'll open it indirectly using h5pi_d and HSDS. So there we go. So that all worked. And this is the same. So with h5netcdf, you don't even need to have any kind of special case logic if you're working with both regular POSIX files and HSDS domains. Okay, so close that. And now with xarray, the same thing. We specify a driver, h5pi_d, and then it's xarray open dataset, file path, engine, and driver. And this will work. And that should be the same. And finally, we get our plot. Okay. So we got all the same information. So the distinction between working with local files and possibly remote resources with HSDS should pretty much be a no-brainer, right? As far as your day-to-day life goes. Okay, that's all I had for the notebook. Any questions after I've gone through all that? I should say there's a lot more to Xarray and H5netcdf than I covered here. I just want to give a taste for people who may not have worked with it before or didn't know that it's so easy to use HSDS with these tools. All right. Okay. Well, thanks everyone for their time. Hope this has been helpful. And again, the link to this notebook is in the forum if you want to try it out yourselves.
All right. Thank you, John, so much.
Okay, thanks, Lauren.
Bye-bye.
Thank you.
Thanks, John.